Hello everybody, and in this video I'm going to be doing a part 2 of partial fraction decomposition. So if you haven't seen the last video, I strongly suggest that you watch the other video unless you already have some previous knowledge of partial fraction decomposition. Otherwise, you should watch the other video before this video. So you should watch part 1 of partial fraction decomposition. So we're gonna start with a simple problem that seems fairly similar to the problem that we've seen before. And our first instinct is just to write a over n plus 1 plus b over n plus b over n, just b over n, and plus c over n. But this doesn't make much sense, because if we simplify this, this ends up being, the right side ends up being a over n plus 1 plus b plus c over n, which we can write b plus c as just d. So that doesn't make sense, because we still need to get this extra n in, but we have no idea how to get it. So how do we do this exactly? So instead of doing this, we might just say, hey, let's just make this an a plus n plus 1 plus b plus over n squared. But again, this doesn't work either, because we also need to include a case where it's just n. So we also have to add on c over n, and only this works. So after we're done doing that, now we can just continue with the normal case of solving for each of A, B, and C by using the heaviside cover-up method. But first, of course, we have to multiply everything by n plus 1 times n times n. So let's just go ahead and do that. So we end up with n cubed plus n squared plus n plus 1 equals a times n plus b times n plus 1 plus c times n plus 1 times n. And from here, it seems pretty simple because we have our normal case again. But there's a problem. We can solve for most of these. We can solve for b by plugging in 0, and both the a and c get canceled out. So b ends up being 1 equals b. So b is equal to 1 if we solve for b. Now, let's plug in a negative 1. So then we can get rid of the b and the c terms. So then we just end up with a equals negative 1 plus 1 minus 1 plus 1, which is equal to 0. So a equals 0. But lastly, we just have c, and we don't have any term to plug in to cancel out just the a's and the b's, because if we plug in a and negative 1, the c still gets canceled out while the b gets canceled out. So we have really no way to cancel out all the terms for cancel out all a and b terms and just leave behind the c. So how do we do this? Well, luckily, since we already found b and a, we can just plug them back in. So we have n cubed plus n squared plus n plus 1 equals 0 times n times n. And note that even if a isn't 0 and that term does not cancel out, this will still work. So you can still use this method even if b or a isn't 1. So 1 times n plus 1. And lastly, we're just left with c times n plus 1 times n. And now you can see where we're going with this, because now, since we only have n terms and just one c, we can just plug in any number. So any number that is convenient enough that still doesn't cancel out the c. And in this case, we can plug in negative 2 or 1. And you might guess that 1 is the best one, probably the best way to go, and that's right. So we're going to plug in 1 into this gigantic equation for n, of course. So then the left-hand side becomes 4, and the right-hand side becomes 1 times 2 plus c times 2 times 1. And then, when we simplify, we're left with 2 equals 2c, so c ends up equaling 1. And that is our solution, and we're done. So, now, after doing our partial fraction decomposition, we know that n cubed plus n squared plus n plus 1 all over n squared times n plus 1 is just equal to, let's just look back at our thing over here. One over n squared plus 1 over n. And we're done. So thanks for watching this video. I hope you enjoyed. I will be including other videos soon, so be sure to check those out too. Thanks for watching.